All right, topic is end-fed half-wave antennas. There's nothing new under the sun with this topic. There has been several articles, many articles in ARRL's antenna handbooks, and other people have put presentations on the net on this type of antenna. So really, what I'm about to present today is really kind of a rehash, but I also have put one up, and I also have all the data from all the sweeps I've done on the antenna and the configuration. So it's kind of taking what people have done in the past, put it together, and made it work. So, and it is not a hard antenna to put together at all. So, with that, we'll start this thing. And okay, now, so what is a end-fed half-wave antenna? Well, it's basically kind of a long wire, and it was commonly known as a ZEP antenna, and it basically came from the first documented use of an antenna used on Zeppelin airships. That's how they communicated with this basically a long wire, or this end-fed half-wave antenna. So that's where it all come from. And actually, you can look it up. There's actually a patent by the Germans on that particular antenna. Normally, the antenna is approximately wavelength long at the lowest operating frequency, and in this case, it's on 80 meters. So it's 100. I cut it for 130. I had to trim it a bit, and then the wire can be connected to the transmitting and receiving radio communications station via tuning and matching system. So the antenna can be used for multi-band operation. I have it tuned for 80 to 10, and with the work bands with basically 2.5 to 1 or less SWR across that. So, and I'll show you the sweeps. So for 80 to 10, the length is approximately 130 feet, but depending on your configuration, height off the ground, things like that, you may have to trim things back, of which I'll show you what I've done. And the layout can be of several shapes, even in a zigzag and things like that. This is kind of like one configuration. This is actually a configuration the way I have it. I have it on the deck, on the pergola, or purgatory, whatever you want to call the thing, and then and then it goes up about 90. Mine goes up about 95 feet to a Manitoba maple, and about 30 feet to a tie-off. So, and the matching unit's right on the pergola, and I'll show you that as we go along. Interesting enough, the current distribution on both the center-fed dipole and the end-fed is basically the same. Again, this is taken from another presentation, and I didn't do this, so but this is his experiments, and at 80 meters at 3.6 megahertz, and we can see the current distribution is pretty well the same. The voltage distribution would also be the same, but I didn't show that. So you're looking pretty well the same on this thing. The radiation pattern on 80 meters this is what it looks like. So the antenna would be along this azimuth, along the x-axis, and that's what this would look like. So the center fed is in blue of a normal dipole, and the red would be in the end fed. So very similar. When you go up to 80 and 40 and 20, then you start to see the lobes starting to be shown here. And again, this is information that was taken from another presentation. This is not mine, but again, this is somewhat of basically textbook stuff. Various suppliers and various people have done the same thing. And also you're seeing that the outer ring is 8.57 dBi, so you're starting to get a little bit of gain on these lobes based on the frequency. And then where'd I go? Yeah, here we go. And this is 10 meters and 15 meters. Again, we see the lobes are being generated as such, and the outer ring here is at 8.41 dBi. So there is some gains, from the antenna based on this information. So basically, the end fit is basically a half wave antenna fit at the end rather than the middle. That's one of the reasons I put that up, because I couldn't put a regular dipole here at my my location. So I said, yeah, let's try this. By the way, I was skeptical of this thing because I've heard people having put them up, they had problems with CMC or common mode current coming back into the shack, and thing didn't work right, and they basically abandoned it. So I started out with the length of wire antenna at 130 feet, and that is very similar to antenna manufacturers like My Antennas and My end-fed antennas, and even MFJ. I used number 16 PVC coated cable, which I got at Princess Auto. You know, its price is right, so that's what I did. The RF transformer unit is a 49-to-1 impedance transformer, and it's rated for 1 kilowatt PEP. I was going to make mine, but I found one from France for $36 American plus $6 shipping. Cost me about $56 Canadian. Landed in my house, and I'll show you pictures of it. It's beautiful, made to balance. So not a balun, unan, because it's unbalanced. They recommend, and this has come from a company called My End-Fed Antennas from Holland, of a counterpoise of about 12.5 feet, of which I put on. I also put an RF choker isolator on. I used an MFJ 915 at about 25 feet away from the transformer. So that's kind of the configuration. And then the advantages is that I thought, well, I want an antenna that I can put up. I can work all bands, that I don't have to have multiple antennas up. It's tunable on all bands, and I'll show you how I tuned it. Like I say, I can work from 80 meters to 10 meters with the work bands. It's easy to install, fed at one end, and you put it up. Mine's not up very high. It's only 15 feet off the ground at the pergola end. It goes up to about 30 feet in the tree, and then down to the end of the property. Very useful for limited space, for if you're running an RV or portable operations or even field day. So I know some people use them for those portable operations, lighthouses on the air and islands on the air, that sort of thing. So, and again, from what I hear, people are quite successful with them, and it's home brewable. So that's a good thing. The issues with end-fed half-wave antennas are this: you've got common mode current over the coax, and therefore imbalance in the feed line, which will cause RF issues in the shack. Kirchhoff's current law, Brent, goes here. And so that you see here where this current at this ground point, or this common point of that auto transformer, it's basically going back. And so that's where you put a counterpoise at this point to basically offset that current that will flow and can flow on the outer shield of your coax cable. And that's the stuff you don't want in your shack. So because of the currents are not in balance, that coax cable will radiate. Unfortunately, this also applies to reception. Thus, the antenna has an increased chance of picking up all kinds of interference in the nearby vicinity of the coax cable. My experience right now is that I have an off-center fed dipole up, and this thing is, the noise reduction is phenomenal because of my configuration. So, but I do have that RF choke in there, and I do have a counterpoise. So the common mode choke filter is placed about a quarter wavelength from the feed point, which I did. At that point, the impedance is low, so the filter will work fairly well. If you don't have a choke filter, you can always use 8 to 10 turns of coax on a, like RG8, on a almost like a 6-inch piece of plastic or drain tile will work. I use the MFJ 915 for this one. The counterpoise, basically, according to Kirchhoff's current laws, the counterpoise will take a portion amount of that current down to and radiate it, or you can put it to ground. Mine is not grounded. And without the counterpoise, current can flow on the outside of that coax cable. That's why we put it on, or that's why they put it on. I put it on, and like I say, I have no RF coming back into the shack. And the counterpoise length should be in the order of 0.05 wavelengths. How's my time, Jerry?
You got all kinds of time now. I just want to make sure that Dave was able to get his work done before 9 o'clock. So you no problems at all.
Here's a kind of a schematic of what this animal looks like. The heart of this is this auto transformer. The auto transformer has 14 turns on the toroids, and then it has 2 turns for the transceiver side and 14 turns on the antenna side. So it's basically an auto transformer configuration. At this common point, I put the counterpoise on, and then further down here I put I did put the RF choke on there, but you don't see that. There is a capacitor, and this came with this tuning unit from France, and it's recommended by, again, all the antenna manufacturers who manufacture these things, like My Antennas and My Infed Antennas. There's a 100 picofarad capacitor across the transceiver side of that coil, and it's about 20 kV of voltage rating. So it has to be fairly high. So the turns ratio is 7, basically 14 divided by 2. The impedance ratio, you do the math, it's 7 squared, or 49. So thus the impedance of this is a 49-to-1 transformer. And thus it goes from 50 ohms on this side to 2,450 ohms on this side. Now I did put a compensating coil in here. It's 6 turns on an 1.5 inch outside diameter. Basically, it's a PVC electrical coupler. I put that in line because the manufacturers, again, the one from Holland and the one from My Antennas, put this in. And I'll explain it a little bit further. And then my length of antenna, I put it out for 130, but actually I cut it down to 128.5. You can also, and I didn't do this, but in one of the presentations by WA7ARK, he actually put a capacitor halfway in the middle of this so that he could actually tune the 80 meter side and bring it up into the 75 meter band without affecting the higher bands. Basically, again, with impedance calculations, it works out to about 500 picofarads, and what it does, it basically shortens the antenna on 80 meters, brings the tuning point up further into the 75 meter band, but it has no effect on the higher bands because it becomes a short circuit to those bands. Conversely, that's what the compensating coil does. It actually helps tune the higher bands down, and I'll show you that here in the next slide. This is what my transformer the matching unit looks like. This is what I bought from France. There's 2 toroids in there. It's an FT240-43. There's 2 of them. It's rated for 1 PEP, 1 kilowatt PEP. If you stack 3 of them together, you get close to 2 kilowatts PEP. If you only put 1 in there, it's good for about 500 PEP. So there's the capacitor that I talked to you about, the 100 picofarad capacitor across the SO239 connector. There's the counterpoise connection, and here's the antenna connection. You can see my cursor, can you? Okay, good. Also, the other manufacturers put an air vent in here because this will heat up. And I know Aubrey, VE1TE has attested to this because he had an MFJ and he had it. You had it pretty hot, didn't you, Aubrey?
Yeah. I had all kinds of RF in the house, and I got fed up with it and I gave it away.
Anyway, you can buy little air vents from Mauser, but I just put a little, it's basically a 1/2-inch electrical coupling or water connection in here. And that's all it is. And it basically will vent the air out. This is a schematic that came from the French unit. And he kind of, the 2 turns and the 14 turns. The 2 turns are right here. They're wound together. Those 2 turns right here, where I see they're these 2 turns right here. And then they keep going along up to the antenna point. The number 14 gauge wire has a Teflon coating on it. He actually put put this in a Teflon tubing, which is absolutely, it's a great design. It's anyway, I showed Aubrey that he was quite impressed with it. Okay. Am I going too fast? Everybody understand so far, or at least got a comprehension of what I'm talking about? All right, we'll keep on going. And this is the explanation for the compensation coil. This coil I made it as part of the antenna, so I wouldn't have to have any joints. It's made out of an 1.5 diameter PVC coupler that you can buy at Kent's or Home Depot or any electrical shop. It's 6 turns of this number 16 gauge wire on it, and basically the wire comes in and up through this hole, goes around the edge of it, and then connects up here, and then it's wound around that, and the same thing on the other side. So when you put it together, this basically holds it together, and it keeps the coil from kind of splitting on you. But I did glue these on here as well. So basically, the compensation coil, what it does, it effectively reduces the resonant points of the higher bands without affecting the lower bands, i.e. 40 and 80. So you see this chart, and again, this is not my chart. The curves in blue are without that coil. When you put the coil in, this is what it starts to do, and you can see it then starts to line up with the 40 meter, 30 meter, 20 meter, and so on, right up to 10 meters. So that coil is very important as part of this whole design. And I found out that when I first started tuning the thing up, it was good. So again, I made this as part of the overall antenna design. This is about 17 inches, I think. Yeah, I've got the calculations of that whole thing. Anyway, I calculated the whole thing out. So I started winding on this side, wound the antenna through it, and then kept the antenna going to the matching unit. All right. There is on top of the pergola, however you want to call it, depending on where you come from. There's the matching unit. The coil's in there. The counterpoise is just going down the side of this all the way to the ground, but it's not connected to ground. It's still floating. The coax is connected, and the wire goes out this way, and you can't see it, but yeah, you go out here. The coil is right there. That little compensating coil. It's about 6 feet away from that matching unit, and then it goes up into this tree to a pulley, and then down to the corner of the lot. And that angle there is about 110 degrees. So that's kind of like where it's pointed. So I asked Jerry if I think at a meet, I think it was a meeting, wasn't it, Jerry? That I says, does anybody have a antenna analyzer? And Jerry says, yeah, we got one. The club's got one. You can borrow it. I says, great. So this is the sweep of the antenna. This is the final sweep. This I took about 2 or 3 of them as I started trimming the antenna, and so this data came right off the analyzer. I connected it to the computer, and then I printed it off. And unfortunately, the program doesn't put all this stuff in here. I had to kind of put those numbers in there to kind of show you. So there's the 80 meter band. There's the 40, 30, 20, 17, 15, 12, and 10. And we've got a match on all of those bands. And I'll show you the individual ones for each of the bands. But thanks, Jerry, for letting me use that. It's a lifesaver, and it's very visual, and you can really have a lot of fun in tuning antennas with the thing. I used to do it back in the day when I used to work for the Power Commission, when we used to sweep microwave antennas. But we had an oscillator, we had a tracking oscilloscope, and we had a XY recorder. Those were the days. Anyway, that's the sweep of that. And then here's the 80 meter band. With, as I said before, if I had put the 500 picofarad capacitor in the middle of the antenna, I would have moved this tuning point probably up around in this area. But I said, I may work up to the edge of 3,800, but here's where I am. So when I'm on the maritime net at 3750, I'm about 2.1, 2.2, and I just use the internal tuner on the IC 7300 to tune that out. But that's the sweep of the 80 meter band. This is the sweep of the 40 meter band. This is beautiful. This is just exactly where I wanted it. And again, this is the final sweeps when I took 1.5 feet off of the antenna, and I left about 12 inches of wrap on the antenna. So before I clamped it, in case I want to do any more tuning. The 30 meter band is probably the worst one of all of them. There, I wanted to get it down in this area. If when I start to run FT8, this is a little high, but again, the tuner will take this out. We're under 3, so I'm okay. I don't worry about it too much. 40 meters was the one I was really concerned with. 20 meters is beautiful. It's right down here at the end of 1.4. Down towards the low end of the CW and the FT8 band. that was for you, Jerry, by the way, because I am getting on FT8, just a matter of time. This is the 17 meter band. Again, it's a little high, but it's still around, under 2 or under. This is the 15 meter band. Again, beautiful. Love this. So again, some of the work bands weren't the best, but the rest of them were right in there. Here's the 12 meter band. It's good. Got no problems there. This is the 10 meter band. Pretty flat, not flat, but clocking around 1.6, 1.7 across that band. So I'm elated by the performance of this thing, and once I put it up, I found that my noise level dropped, but that's due, I think, in part because I have the other antenna, the off-center fed dipole. It's coming because I don't have my 60-foot tower up anymore. It's on a mast that's on the house with a deep fringe antenna on the top of it, and it's just underneath it. And my electrical entrance is about 10 feet away. I figure I'm getting hash coming in off the distribution system. And when I switch from that antenna to this antenna, my noise drops from an S6 to an S1 or less. So I've been quite happy with it. This is a kind of a bill of materials. You can build your own transformer if you want. It's not a big deal. I bought this off eBay. You can search eBay, you put in a 49-to-1 transformer, and this guy from France will appear, and it's a beautiful little thing. So anyway, the other stuff is, PVC box. You can buy a nice Mauser air vent, but I just use something cheap. And again, this is just all stuff that I bought local, either from Home Depot or Princess Auto, etc. But most of these things are all stainless steel, so it's not going to get kind of damaged later on in life. So my conclusions on this is that for my QTH, it may be different for yours. So you have to take it in stride. My noise level has been reduced significantly due to the location, and because I'm away from any interference from the distribution system, and it's kind of like on the other side of the house. I didn't want to put up multiple antennas, like for one for 40, one for whatever. The only thing that the antenna won't do, it won't do 60 meters. So if somebody's looking to do 60, it will not do it. It's like 9-to-1. But I do have just a normal dipole for 60. It's workable on all the work bands, with the exception of 60, and VSWR is less than 2.5-to-1. It's easy to build. It took me no time to build this thing once I got the transformer, and it's kind of got me back in the hobby after 25 years of doing other stuff and getting back into it. I wanted to. I can't put up beams anymore. I don't want to put up beams anymore because I don't want to climb anymore. So it's kind of got me back in the hobby, and I'm really quite impressed with this antenna. I had a lot of reserves about it. I thought I heard so many negativity about it with noise on it, with CMC current modes coming back into the shack, etc. But by doing those counterpoise, by doing the RF choke, it's eliminated that. So I'm enjoying a reduced noise HF band experience now on 80 and 40, just having a great time. So I want to acknowledge there's a couple things here. My antennas on their website, they had a lot of information, and so I want to acknowledge them because that's basically their design on this antenna. It's not mine. I can't take anything for that. Steve Ellington, N4LQ, has a lot of information on this antenna. If you look him up on the web, he's got a tremendous amount of information. So I gleaned a lot from him. And then Mike Mladejovsky, WA7ARK, he had a presentation on this. And again, I took some of his information, put it on that slide. So that's his, not mine. And I want to thank the club for the use of that RIgExpert analyzer. It was good. So thanks, Jerry. Easy to use, great to hook to it's easy to run on your computer, and then you can save the data and see what you got for down the road. So that's it. I guess it's any questions.
I have a question. It's John. What about that MFJ choke? Is it located outside or inside the house?
I know that MFJ in their documentation, they say to put that. Are you talking about the matching transformer?
No, I'm talking about the MFJ choke, the 915.
Oh, it's I've put it outside, John. It's underneath the deck because I wanted it about 25 feet away from the matching unit. So it's underneath the deck, and then the feed line goes through the wall into the shack. So it is outside. I would recommend outside. I wouldn't put it inside.
Thanks.
Murray?
Yes.
I was thinking of actually I have a 9-to-1 barrel, and I was wondering if I could use it with one of these, but maybe I'd have to adjust the length of the counterpoise or position of the choke or something like that. Any thoughts on that?
Yeah, you can use that. Actually, Palomar, I was looking at one of those. They called it just an end-fed antenna. And if you look up the Palomar Engineering website, they have a whole bunch of information on an end-fed antenna. and they use a 9-to-1 balun. And I think they use, I've got information on it, Charles. I can send it to you if you want it, because I documented all this stuff in another kind of a Word document, so I could find out, do I want to go with a Palomar Engineering 9-to-1, or do I have to put one of these 49-to-1 baluns in? But they do have one. They have all kinds of documentation on it, and for basically a multi-band operation antenna, Charles.
Okay, Maria, just send it to my other call sign. Thank you.
Yeah, no, I'll do that. I'll send that to you, and you can have a look at it. And again, go to the Palomar Engineers website. They have a lot of good information.
I will. Thank you.
Murray, I wanted to thank you for the presentation, and I thank the club for letting me join the group tonight. I'm going to have to leave now, so I'll say good night to everybody.
Good night, Aubrey.
Thanks, Aubrey, for coming on. We'll talk on the intercom.
Yeah, that's for sure. You'll have to tell the fellows about that. Everybody should try that one. I just want to say before I go, when I first became VE1TE back in 1947, that's where I was, and so I'm quite familiar with the area there. And but thank you, everybody. I really enjoy being here tonight, and wish everybody a great week.
Okay.
Anyway, well, thanks again, fellas, and I was a member of VE1TE back in when it first started. It started around 1947-48.
Nice to see you, Aubrey.
Yeah, bye now.
Thanks
See you,
for
Aubrey.
coming, Aubrey.
Yeah, good night.
Yeah. Aubrey and I we have an intercom system. We go back and forth. It's called Dude Star. It's basically voice over IP on, and you just need a computer. You need a DMR ID number and a Brandmeister ID, but you basically go to all these, fusion reflectors, DMR reflectors, D-Star reflectors. There's a whole bunch of them. We get on there with a bunch of guys from the States, and it's like an intercom. He's always on a certain reflector, and I call him up and say, Aubrey, how you doing? And if he's there, he'll call me back, and it's just like a telephone almost. We call it our intercom system, so it's kind of fun. Anyway, any other questions?
Yes, Maria, it's Art.
Yes, sir.
I have a question about how long is your coax feed line from the antenna itself to the final point of connection at the rig?
50 feet.
Okay.
And I tell you why, Art, is that I had 100-foot length of coax from my previous days. I dug it out, and I wanted to put, I needed 25 feet from the matching unit to the RF choke. So I cut 25 feet off, then I cut another section off, and I said, I'm not going to cut any more of this off because I may want it for something else. So I just put another connector on it, put it on, and normally it should have been only maybe 25, 30 feet, but I had this extra, I just coil it up under the deck and put it on there. So
with that background information you got on the design, do you have any feeling for what the mismatch would be at the antenna terminals?
You mean at the matching unit itself?
The impedance mismatch at the connection point of the antenna and the coax.
Oh, the matching transformer takes it from 50 ohms and puts it up to 2,450 ohms.
Okay.
So that's part of your mismatch right there, because you're feeding it not in the center, you're feeding at the end of the antenna. So your impedance is high at the end of the antenna, and that's why the 49-to-1.
Do you think different bands would benefit from a tailored impedance if there was such a thing possible?
Well, how you tailor the impedance, Art, is with the use of that compensating coil, 6 feet out. That will compensate for the higher bands, like anything above 40.
Yeah.
And then then if you experiment with the capacitor in the middle, then you can start moving the 80 meter and the 40 meter up.
Right. Where I was going with that is with that antenna analyzer you were using, since you can get the actual reactive components at your transmitter,
Yep.
and you know the exact length and velocity factor of the coax,
Yep.
for each band, you can actually tell what the total cable loss is due to the change in mismatch at the antenna connection point to the coax.
Oh, yeah, yeah. I mean, the antenna analyzer will do a TMR for you. Or sorry, TDR.
Yeah.
And so I did that, and I looked at Smith's charts and things like that, but I didn't put that in any of their presentations. I didn't want to complicate the thing.
Okay.
So, but
Yep.
no, you can look at it. Will give you a Smith chart output, and you can actually look at the antenna point, the actual, R J omega L or J omega impedance at that point.
Yep. Okay.
But for all intents purposes, when I put the analyzer, I got, like, say, at 7.050 megahertz, I got 1-to-1, and I checked it with Kenwood SWR meter and a Drake SWR meter, both the same, 1-to-1.
Good.
So I says, I'm happy.
Thanks for the detail.
Yeah. Thanks, Art. Anything else?
Murray,
Yes, sir.
you know how you have that, I think you said it was 12.5 feet of counterpoise. What if you had two wires, one was the 12.5 and one was another length? Could you get it to come down on a little, maybe 30 meters or one of those other bands by playing with that?
Yeah, you can. I think one of the other presentations, I think that WA7 ARK did that. That you could. No, sorry, my fault. My infid antennas. It's a company in Holland. They did that. So you could put different lengths of counterpoise on.
So two counterpoises.
Yep.
You have the one now.
Yep.
Okay.
Yeah, I just put one because I was lazy.
Murray, thanks very much for the presentation. We got a couple more things to cover before the end of the meeting here, and really a wonderful job. You've done a great job on that presentation. And
if anybody wants the presentation itself, I've got it. You can either have it in PDF or PowerPoint format. So if anybody wants it, let me know.
We need your explanation along with it, so that's why the video.
Like I say, nothing new under the sun. It's been all talked about before. It's just said, okay, let's put all this stuff into practice and see what it does. And so,
and you did a wonderful job.
Thank you.
Okay.
And I saw that hand, Charles. I'll send the presentation to you as well.